Hi, it's the first lecture in Laplace Transform. So what's Laplace Transform? Laplace Transform belongs to a class of transforms called linear integral transforms that have such a property. The Laplace Transform converts linear time invariant differential equation into algebraic equations that are generally easier to solve. So you may ask what is the difference between Fourier transform and Laplace transform. If you look at both formula here, this Fourier transform, you'll find that the integration from minus infinity to infinity, the signal x of t multiplied by e to the power of minus j omega t. Laplace transform is more general. Instead of multiplying the function but by e minus j omega t multiplied by e to the power minus s, and s has real part and imaginary part. So that's more general. The drawback of continuous time Fourier transform that it can be defined only for stable systems. However, Laplace transform can be defined for both stable and unstable systems. Well, so that's the formula used to find Laplace transform. Let's just see some example how to find Laplace transform for some signals. Example 1 will have a unit step function. So unit step function is defined like that. At t equals 0 and greater than 0 be equal 1 and 0 before that. So you can write like u of t is equal to 1 when t greater than or equal 0 and 0 if t less than 0. To find Laplace transform, you will say x of s, because this is our signal, we're going to find its Laplace transform. So x of s will be equal to the integration from minus infinity to infinity. I'm just writing the definition. X of t e to the power minus st dt. And since this function or this signal start from 0, so the limit of integration will be start from 0. X of t is equal 1 here. So I'll replace x of t by 1. Now the integration will be equal to e to the power of minus st divided by minus s, and the limit of integration from 0 to infinity. If you are going to change this sign from negative to positive, you will say e to the power of minus st divided by s, and then you change accordingly the limit of integration. So x of s will be equal to 1 over s, and then e to the power minus st, you put t equals 0 minus e to the power minus st, you put infinity. So this value is equal to 0 and this value is equal to 1. So the final result will be 1 over s. So Laplace transform of unit step is equal 1 over s. Let's take one more example. The signal x of t is equal to the e exponential, so let's say to the power of minus at ut. And we know that once you multiply any signal or function by u of t, it means that's defined only for t greater than or equal 0. So Laplace transform will be equal to, should be from minus infinity to infinity, so it will be from 0 to infinity, and the function is equal e to the power minus at multiplied by e to the power of minus st dt. When you multiply the exponential, can you add the power? So you have e to the power minus, and you can write s plus a t dt. Again, the integration will be equal to the e to the power of minus s plus a divided by minus s plus a, and the limit of integration from 0 to infinity. And we'll do the same thing. If you change this negative sign, you'll change the limit, flip the limit will be here 0 and infinity. Now we'll substitute. You have 1 over s plus a, e to the power of minus 0, and then e to the power of minus infinity. That will be equal to 0, and that's equal to 1. So the result will be equal to 1 over SA. So the Laplace transform of e to the power minus at is equal 1 over SA. And once you know that, you can use this as a property. What I mean by that, so if you have another function and it look like that, e to the power of minus j omega t ut. So you don't have to do the integration again, because now we just proved in the previous example that e to the power of minus at ut Laplace transform will have 1 over s plus a. So all what you're supposed to do is just to compare what's your a here. Your a is equal j omega. So just use the result. So Laplace transform be equal 1 over s plus j omega. And that will be the result. All right. I hope that was helpful.